Hey guys, and welcome to the Dr. GY lectures. And so, in continuation with our previous topic, we are going to see about the next another advanced level of microscopy, that is what you call that scanning tunneling microscope. So, in our earlier session, we used to see the scanning electron microscope. So, both are the working principle is same. Both are having the electrons. The electron beam has been strike over the sample, and whenever the electrons strike over the sample, it can produce some kind of reflection, and some of the rays which can be due to the low intensity that electrons get scattered. That is what you call the random scattering, and based upon that we can able to study the surface topography of the given sample. So in the same way, we are going to see the another method of microscopy, that is what you call that scanning tunneling microscope. So it is a powerful instrument for which can be used for imaging the surfaces at the atomic level. So that is a fundamental thing. Okay, it was developed by Gerd Binnig and Heinrich Rohr, and both are the Nobel Prize winner in physics during 1986. And for an STM, there is a good resolution. It is a good resolution which is considered that minute level like a 0.1 nanometer size. It can able to give a lateral resolution, and for 0.01 nanometer depth resolution has been find out. With this resolution, that individual atoms within the materials are routinely or which can be imaged, and it can be manipulated, and this STM can be used not only in ultra high vacuum but also in air, water and various other particles. Even if water bubbles which has been present over the surface, and the type of bubbles which we can see over the sample, what is the deflection angle of water when we are passing the light rays over it, and what is the water contact angle, even it can be analyzed up to the nano micrometer level. Okay, so here the diagram which you have seen is here that it is about their tip. Whenever the tip has been placed over the object, this tip can generate some pulse. So that pulse can be transferred to the tunneling current amplifier, which can improve the intensity. So whenever there is a irregular surfaces, or there is some invariation of the particle, it can generate some pulse to the amplifier, and also it can transfer that sensing element by through the distance control and the scanning unit. So with the help of this, what happened, that the intensity level of electron beam has been increased by through this connection, and this piezoelectric rays which has been passed over the surface because of the physical contact, and it can generate the information in the screen. And those who are doing the research in this area, their topography level nanometer size has been displayed in this has been displayed by using some visual screens. So here you just see there is a fiber over that, inside we having a twisted fibers are there, and there is a short fibers are there, that the sizes over the fibers and the gap between the tide levels, it can be up to the micro and also nanometer sizes. So this nanometer sizes has been studied by through this by using passing the piezoelectric tubes. It can improving the sensitivity of detection, and based upon the detection it can conveys the information to the screen. Okay, so that is why we are using the STM as the another method of microscopy which can use it to determine at the nanometer level. Okay, so this STM is totally based upon the quantum tunneling concept. So both methods are basically working on quantum tunneling concept. When a conducting tip is as brought very near to the surface, it's to be examined, and it can be applied between the two, can allow the electrons to tunnel through the vacuum and between them. This resulting tunneling current is a function of a tip position and applied voltage and the local density of the states that can be represented by LDOs, and information is acquired by monitoring the current as the tip portion scans across the surface, and it can usually depends on the excellent vibration control and the sophisticated electronics has been used over the days. So that is why these atoms has been studied in the micro level, and here there is a detection of that electronic panel has been used for this study, and by passing the atoms on over the panel it can generate some information. Okay, so with this I just wind up, and we will continue on next session with a new topic. Thanks so much.